This question is all about proving trigonometric equation actually. Now we need to prove that this term in the left hand side is equal to the term in the right hand side. Now we have two um, questions. Now the first one was sine bracket open a plus b divided by cos a cos b is equal to tan a plus tan b. Then the next question was cos bracket open a plus b bracket close cos bracket open a minus b bracket close is equal to cos square a minus sin square b. Now let's begin. The first one we have sine a plus b divided by cos a cos b is equal to tan a plus tan b. Now let's use the left hand side to solve this particular problem. You have sine a plus b divided by cos a cos b. This is equal to, now expanding using trigonometric identity to expand this particular one at the numerator, you have sine a cos b plus cos a sin b divided by cos a cos b. So, and this is the same thing as saying sin a cos b divided by cos a cos b plus cos a sin b divided by cos a cos b. This is just the same thing as saying a plus b divided by c is equal to a all over c plus b all over c. It's just the same thing. So when you look at it critically, you see that this is the same, so you cancel out. So this is also common, it cancels out. So now you now have, what you have left is sine a divided by cos a plus sine b divided by cos b. And this is the same thing as saying tan a plus tan b. Since we know that tan theta is the same thing as sine theta divided by cos theta, so we use this expression. So now we have seen that the left hand side is equal to the right hand side of the equation. So now let's look at the b part. The b part will have cos a plus b cos a minus b is equal to cos square a minus sin square b. Now when you look at this thoroughly, we can now say, let me just use an analogy. I can say cos p plus q is equal to cos p cos q minus sin p sin q, and also cos p minus q is equal to cos p cos q plus sin p sin q. So let's say this is equation 1, this is equation 2. So adding equation 1 and equation 2 together, you have cos p plus q plus cos p minus q equal to, when you add them together, this will cancel out. You now have 2 cos p cos q. So from this analogy, you have cos p, 2 cos p cos q is equal to cos p plus q cos p minus q. Now dividing both sides by 2, this is plus, sorry, it's plus here, so I just interchange it. So now you have, now if these two cancels here, you now have cos p cos q equal to cos p plus q plus cos p minus q. Now from here, now you notice that if you compare the left hand side of the equation where you have cos a plus b cos a minus b, which is this, the left hand side, you can see that it's similar to this, meaning that p is equal to what? A plus b, and q is equal to a minus b. Now let's call this equation 3 and equation 4. Now adding equation 3 and 4, adding equation 3 and 4, you have p plus q equal to what? This will cancel. You have 2a. This is equation 5. Now subtracting equation 4 from 3, you now have p minus q is equal to 2b, equation 6. Now we have gotten our q minus, now you look at it thoroughly, our p and q is this and this. So now have to replace. So now this is the left hand side. So now let's now write this whole thing in terms of a. You have cos a plus b cos a minus b will now be equal to, now if you place this, now p is equal to what? Now p is equal to a plus b. Now let's look at it. We have cos p cos q equal to this over 2, sorry, there's 2 here, over 2, look at it here. So we'll now say cos p plus q plus cos p minus q divided by 2. So this is what we're using. Now that means cos a plus b cos a minus b. So now we have chosen this to be our a, our p. This is p now, and this is q. So, and here p plus q is cos. This p plus q, we got it to be 2a. So what we're going to do is, anywhere we see p, we replace it with this, because p here is equal to a plus b. Anywhere we see q, we replace with a minus b. Then anywhere we see p plus q, we replace it with what? 2a. So that here will be 2a plus, now P minus Q is what? Cos 2P divided by 2. So this whole thing is the same thing as this. Now because you know P is equal to 6. Mm, P is equal to this, Q is it is y P plus Q in equation 5 is 2A, P minus Q in equation 6 is 2B. So we just replace it. So we have just used this formula. So now, so we have gotten this. So this is the same thing as saying 1 over 2 into cos 2A plus cos 2B. Now we can expand this. You know, cos 2A is the same thing as A plus A plus cos 2B. 2B is the same thing as B plus B. So how? Now if we expand this, you have this to be cos A minus sin A plus this one also be cos B minus sin B. So the whole of this is the same thing as 1/2 cos A will give you cos square A minus sin square A plus cos square B minus sin square B. Now let's go to the next page. So it means that cos A plus B cos A minus B is equal to half cos square A minus sin square A plus cos square B minus sin square B. Now, if you look at the expression, they only want cos to have the angle A and sine to have the angle B. So with that understanding, only cos will have angle A and only sine will have angle B. Now we have, according to trigonometric identities, we know that sine square theta plus cos square theta is equal to 1. So it now implies that, so from this understanding, it implies that if you move this to this other side, you have sine square theta to be equal to 1 minus cos square theta. So this is an identity. Now if you now leave this one and move this one, you now have cos square theta equal to 1 minus sine square theta. So we're going to use these two expressions to simplify this further. Now, since we want only cos to have angle A, to have the angle A, so what we're going to do is say half times cos square A. Now we're going to change this sine square A to cos A. To do that, we're going to apply this rule here. Because sine square theta is equal to 1 minus cos square theta. So now sine square A is equal to 1 minus cos square A. So what we're going to do is say minus into, now that means we use this bracket minus, so minus, now you now have to write with this expression sine square A will now be 1 minus cos square A, since only the angle A will only bear cos from that expression there that we want to prove at the left and the right hand side. So now in this also case, only angle B, sine will only bears angle B, So this we need to change this. So now we have plus. Now you see cos square theta is equal to 1 minus sine square theta. So we're going to change this to 1 minus sine square b, which is this. So now minus sine square b, all in brackets. Now let's open up this bracket. You have cos square a minus 1 minus times minus, you say plus cos square a, then my plus 1 times 1, you have plus 1, plus times minus, you have minus sine square b minus sine square b, or in the brackets, you say half times, you now have this cos square a plus cos square a, you have 2 cos square a minus 1. Then here you have plus 1 minus sine square b minus sine square b, you have minus 2 sine square b. Now you have half into, now here you have 2 cos square a. This and this will cancel out because they are equal and of different sign. Now you now have, what you now have left is 2 cos square a minus 2 sine square b. Now this is the same thing. So now when you check, the 2 is common, you factor it out, you have half times 2 into cos square a minus sine square b. So these two will cancel out these two. You now have, what you have left will now be equal to cos square a minus sine square b. So it has been proven that the term on the left hand side is equal to the term on the right hand side. So thank you for watching to the end. Have a nice day.